Hey everybody, it's Tony from Adafruit, and I wanted to do a second stream on using Bluetooth Low Energy with the Raspberry Pi. And this time I actually have something kind of fun and new, so I've got the Raspberry Pi 3, and so we'll check this out. So the big thing with the third version of the Raspberry Pi is that it has Bluetooth, both classic and low energy, and also Wi-Fi built into it. So we'll see how this goes. And hopefully the stream is coming through okay. Wirecast is throwing up some warnings, so we'll see if it's dropping frames or not. So let's jump to a workbench shot, and hopefully this will get a little bit nicer and not drop any frames. And let's see. So here's the workbench, and let me put my face in here also. So you can basically see this is the Pi 3 right here. And it looks just like the Pi 2, same form factor, very similar size, same connections. You can connect all the same devices to it. But the big thing is that it's got the little Wi-Fi and Bluetooth Low Energy radio built into it, in addition to being faster. So it's got a better ARM Cortex processor, and so it gives you a little bit more flexibility in what you can run. And so I've only had it a couple days, but so far it seems to work pretty well. And I've actually been playing with the Bluetooth Low Energy side of it a little bit and having some luck with that. And so it's something that I'm not fully sure that the Bluetooth Low Energy is, maybe certified as known working well. I haven't run into any problems with it, but I have heard that there might be some issues that people have been having with it. So it seems like it's a little bit kind of beta. And in general with the Pi, like Lady Ada saw in a stream yesterday, the serial connection doesn't run at the right baud rate, so early on there's always going to be a few bugs and things like that. But keep an eye on the raspberrypi.org website, and I'm sure as there's new versions and new firmware, we'll see how it goes. So I wanted to maybe start with just a quick little recap too of the first stream that I did, and maybe let me switch to the desktop view here to do this one. So let's see, let's jump to this, and basically so the first stream I did, so this is part 2 and what will probably be maybe 3 parts on Bluetooth Low Energy. First one was just an introduction to Bluetooth Low Energy. I talked about what are the different things in the Bluetooth protocol, what makes Bluetooth Low Energy more interesting compared to Bluetooth Classic, and why you might want to use it in certain projects, and kind of dove into how to compile and use Blues, B-L-U-E-Z, the Blues library on the Raspberry Pi, which is how you can talk to Bluetooth devices, both low energy and classic. So we went through and kind of compiled it and saw some basic usage using a little control program that it has. And one thing that I did since the last week, since that last kind of first part broadcast, I made a little guide in the Adafruit learning system. So if you go to learn.adafruit.com, you should be able to see this guide. And this is just basically a walkthrough of all the steps you need to take to install Blues on the Raspberry Pi. So what I did in the video effectively just kind of wrote it down, so you can kind of go through and see the commands to run here. I did this because I realized the Blues installation instructions kind of changed a little bit with the latest Raspberry Pi versions. So everything's using systemd to run services, and the latest version of Blues can use systemd. So wanted to just make a new guide that says, here's the definitive way to install Blues from source. You could install it from the apt-get repositories, but like I mentioned before, you get an older version that might not be as up to date. Usually you want to get the latest version for Blues, especially if you're dealing with Bluetooth Low Energy stuff. So check that out on the learning system. It kind of just gives you some info and also kind of links to the previous video here. So let's see what I wanted to do this time now. So part 1 I talked a little bit about what Bluetooth Low Energy is, and we just manually connected to the Pi and controlled some stuff. In this video, I wanted to look at a library you can use to write some code to actually control Bluetooth Low Energy devices. And it's a JavaScript library called Noble, which is basically, you have to use nodejs to use this library. And it might sound kind of scary and you might not be familiar with JavaScript, but I'll show you that the code really isn't that complex. And if you're used to a language like Python, it's actually not super hard to transition to JavaScript. It's just a slightly different flavor and syntax of how it works. But there is some interesting stuff that Node.js does that I'll kind of talk about, how everything is very asynchronous, and so the coding style that you use might be different from what you're familiar with Python and some other languages. So we'll look at that, and then maybe first too, we'll also look at the Raspberry Pi 3. We'll connect to it, and I'll just show you a little bit with Blues. We kind of poke it a little bit and see how it works. All of this I'm going to do on the Raspberry Pi 3 right here, so hopefully it works. Like I said before, it's a little bit of uncharted territory, but it seems to work so far for me. So let's see. Let's start out with the Raspberry Pi. So let's see. Let me move some stuff out of the way. We don't need a Wirecast over there. So I'm connected to my Pi 3 right here, and let me bring up also my workbench in the corner so you can kind of see here. So like here's the workbench up here, and it's just nothing too crazy. I have the Pi, and I'll come to what this is down here. This is the Adafruit M0 BLE Feather, and so we'll see why this is interesting in a second. But basically, I'm connected to my Pi. This is the Pi 3. I've just loaded up the Raspbian Jessie operating system, the latest version on here. I think it's the February 26th release, and it boots up. It feels just like a normal Raspberry Pi. There's not much of a difference. It does boot a little bit faster, more than a little bit. I mean, it boots like within probably about 10 seconds or so. It's a very quick boot. And the desktop I play a little bit with too is nice and fast, so it's definitely a lot quicker. Now I've gone ahead and I've installed Blues on here. I've installed the latest version of Blues. I just followed my instructions exactly from this tutorial. So I went through, downloaded the source code, compiled it, and installed it. And I have Blues running, so if I run systemctl status of Bluetooth, this is telling me that the Bluetooth service is running, and it's running with that experimental flag. So that's all good. So Bluetooth is running, so I can run that Bluetooth CTL command that we saw before. So this opens up the Bluetooth control program. Hopefully I'm back now. Folks in the chat, say if you can see this in some way. Everything's telling me that it's good quality, so we'll see what's happening. Okay, cool. I think we're back. So live internet, that's what happens. You just kind of have to roll with it. So anyways, so I was just running the scan command, so I turned it on. So it's scanning for Bluetooth Low Energy devices here. You can see it found one. So it actually found this Adafruit bluefruit LE device right here. I can connect to a device. So if I connect to this device here, I just have to copy out the address and then paste it in there. And so it's going to connect to it, and it seems to connect. You can see this little blue LED comes on the device when it's connected over there. And it looks like it just pulled down all the characteristics and things for this. So as far as I can tell, I mean, it looks like Bluetooth Low Energy, or Blues at least, is working on the Pi 3. I can't say for sure. I haven't tested everything, but it's definitely worth trying out when you get the Raspberry Pi 3 and see how things work. So let's see. Let me disconnect from this device, and then we'll close out of here. So yes, that's the Blues command. Seems to work pretty well, the Bluetooth CTL. So what I wanted to do now then is to think about, okay, so you can use that Bluetooth CTL command. That's good for like manually connecting to a device and being able to control it. But if you really want to automate something, you probably want to write some code that you can run to do that. And so I'll show you this Noble library, and maybe before I do that, I'll kind of mention an application I built using the Noble library that's also really helpful for interacting with Bluetooth Low Energy devices. So it's called the Bluefruit LE desktop application, and you can find it at this GitHub repository, Adafruit-bluefruit-le-desktop. I'll put links in the description when this is up on YouTube also. And it's basically a little desktop app that runs on Windows, even Windows 7, Mac OS X, and Linux machines. And it gives you a little kind of graphical interface to connect to a Bluetooth Low Energy device. You can interact with certain services, like if the device looks like a UART, like a serial device, you can send and receive data with it. And so what I've got going here then, this second little piece of hardware over here is the M0 Bluefruit LE device. So this is basically the AT-SAMD21, which is a ARM Cortex processor. I'm getting some message. Let's see, is the stream back? I think the stream is back. Okay, hopefully the stream is back. We'll see how it's going. This is a little bit of a rocky start, so we're just going to charge through it. If the stream is totally messed up, this is being recorded locally, so this will go up on YouTube, and you'll be able to watch it later. Unfortunately, it's just kind of have to roll with how the bandwidth is going. So okay, so I think we're back now, and just to kind of recap what I was doing. So I was just talking about there's a Bluefruit LE desktop application that I created using the Noble library. And it's basically a cross-platform app you can use to talk to Bluetooth low-energy devices. It's still in beta, I would say. It works, but I'm not fully sure that everything's fleshed out. But it lets you connect and interact with a device. And so the device that I wanted to look at was the Feather M0 Bluetooth low-energy Feather that we have here. So this is the SAMD21. It's a nice little ARM Cortex M0, and it's connected to the NRF 51822 Bluetooth Low Energy module. And so with that device, it basically acts like an Arduino, so you can run code on the M0. It's a powerful Arduino, so it has a lot of memory. It's just like the Arduino Zero. And I've got a little application running on it that I'll show. This is just the Bluefruit library UART demo. And so this acts like a serial device where you can connect to it with a Bluetooth device, send and receive data, and see how things work. So I've just loaded up the default sketch, and I'll open the serial monitor here so we can kind of see what's going on with this device. And let me reset the device also, just to make sure we get it in the good state. So I'll just upload the code again to it. So compile it and upload it, and this will send the code to the device. So yep, it just sent the code. And now if I look in serial monitor, so this is kind of the default. You run this sketch, you open the serial monitor, and it'll wait for a device to connect to it. And so the device that I'll have connect to it is my Mac right here that's running this stream. So I'm going to run the Bluefruit desktop app that I was just mentioning. So it's this Bluefruit desktop application. The nice thing is you can just grab it from the releases branch. I have a precompiled version here. So this works on Mac OS X, Linux, and Windows machines, even Windows 7. And it's because it's using that Noble library. And I've downloaded it, and so I'll just run it. And this app is actually built using a framework called Electron, which is what the Atom text editor a lot of people might use. They built a little framework to basically run a JavaScript application on a desktop. So you write your code as if it's like a web application with HTML and JavaScript, but you can link to different nodejs libraries, things like Noble, and use those. So I ran it. You can see it starts out and it's in a scanning state. So it's looking for Bluetooth Low Energy devices, and it's actually listing the ones that it finds. So it found this little Adafruit Bluefruit LE device, and that's actually my little device right here on the workbench. So I'm going to click this to connect to it. And you can see it goes through the connection, and there's a little phase. It has to discover all the services. And once it connects, it actually will just go through and list all of the services that this device exposes. So this device exposes some pretty standard things. There's a device information service. It'll list all the characteristics inside of that service. So there are things like, here's the manufacturer name string. I can even click this read, and it's going to read the value. So it says this one's set to Adafruit Industries, or the model number. You can click that, and it's the BLE Spy Friend. So this will let you see any kind of a device that has a Bluetooth Low Energy attributes and things. You can see other services. So this service here, there's no name and no type because this isn't a standard service that the Bluetooth Special Interest Group publishes. So this is actually one that I think Nordic defined, and it's the Bluetooth UART, or serial protocol. And so it just has a couple characteristics. One of the characteristics is for sending data, and the other characteristic is for receiving data. So it's basically how you can send and receive data, just reading and writing those two characteristics. But again, there are a few other characteristics on this device also. Like there's, if I remember correctly, like a firmware update characteristic and service. So that's kind of interesting on the information tab. Now the UART tab here, I can click this and this actually opens up a little text console. And so let's kind of compare both of these. So this over here is the Arduino serial output. So this is the serial output from my little Bluefruit M0 friend Feather there. And you can see it actually realized that something connected to it and a little blue LED comes on the device. So it knows that my Bluefruit application here has connected to it. And this Bluefruit app is running on my Mac. So it's using the Mac's built-in Bluetooth radio. So it's connected. So let's send something from the Mac to the device. We'll say, you know, hello world. We'll click the send here, and you can see actually something happened over here in the serial monitor. So it'll print out all of the characters that it receives, and it prints both the ASCII and the hex, so you can just kind of see the raw data. But you know, there it is, hello world, HELLOWORLD. So it's, you know, received the data. Now I can also go the other way. I can send from the Arduino over here. So let's say, you know, hi, I'm good, and we'll click send, and we should see it just received it over here. So that's pretty cool. That's kind of useful. You know, if you've got a UART device, I'm running just the basic sketch that's included in the Bluefruit library. So this, you know, lets you talk to a device effectively just by loading this sketch and then running this little application here. Now there are some other kind of tabs in here. So there's a control tab. This lets you kind of emulate the functions in the mobile phone applications that we have. So there's the Bluefruit iOS and Android app, and so they give you a little control pad interface, and this lets you emulate that. Like if I press one of these, you'll see some what looks kind of like garbage data, but there's actually a certain format for the commands that are sent, and so it sends a special format to say, you know, hey, this button was pressed and released. There's a color picker also, so you can kind of choose a color and send it to the device. You know, let's say send that, and it'll again, you'll see it sends what kind of looks like some garbage data. And then there's also this crazy BNO 055 tab. This one won't work right now. So if you connect the BNO 055 absolute orientation sensor to a little Bluefruit friend device here, you can actually use it as like a 3D kind of mouse or orientation device, and it'll render a little 3D model in here, and you can actually rotate it around. So maybe in a future video I'll kind of show that demo. But the thing I think that's interesting here is this UART service, so that, you know, I can send and receive data pretty easily from this little graphical interface. And it's reasonably full featured. It's like you can disconnect from the device and it'll go back to the scanning mode, and then you can go back and reconnect to a device. And if the device disconnects, it'll try and reconnect. So, you know, kick the tires with it, try it out a little bit. Again, I consider it kind of beta, just because, you know, there's a lot of variables with Bluetooth Low Energy, especially trying to support all these platforms. But it's pretty kind of basic and gives you kind of what you need. So what I wanted to do is a real quick little thing then. Let's modify the code. So you might have noticed I have something connected here. I have a little LED connected to the Feather right over here, and it's just connected to one of the digital inputs. And if I set that input high, then I can turn on the LED. And I just have a resistor here. It's a 560 ohm resistor just to keep the current low, so that, you know, you don't burn out the LED. And what I wanted to do was actually modify the code for this sketch. So I won't get too much into the code for this, but basically the main loop for this, you know, it waits in the setup for something to connect, and then in the main loop it just receives data that's been transmitted from the connected device, prints it out to the serial port, and then just basically does nothing. Like if it receives data from the serial console, it'll just send it over to the device. But the code for it isn't that crazy. So you know, the Bluefruit connection, the UART connection, looks like a serial object in the Arduino code, so that you can send data over that Bluetooth connection just using a print statement like right here. So this first little block is basically looking to see, has any data been received on the serial monitor? So like if I type something in up here and click send, then this will receive all that data, just saves it into a buffer, and then on this BLE object it does a print, which is going to send the data over to my connected device over here. So you'd see it show up in the received over here. And then it just goes to check and see, okay, is there any data available? So has the machine that's connected sent any data over to the UART device here? And it just pulls each character down and prints them out to the serial console over here. So what I was thinking, a real simple thing, I want to add like a command to turn on and off the LED. And I was thinking if you sent like a plus sign, that could turn on the LED, and if you sent a minus sign, that could turn off the LED. And that's really easy because it's just one character, so I don't need to look for like a word or a special command that I wanted to receive. So it's pretty simple to parse this. So what I want to do then, I want to go into the setup function, and the setup is just doing some basic setup to initialize the library, you know, create kind of the Bluetooth connection and wait for a device to connect to it. So in my setup then, because I'm going to use a new digital input, I need to set the pin mode. So I'm going to set the pin mode, and it's pin number 5 that I have this connected to. And I want to make that an output device. So we'll do pin mode 5 as an output. And then just to be safe, let's just turn off the LED immediately when we start. So we'll say digital write 5 low. So when I set the value of this pin low, it'll turn off the LED. And then now in my main loop, like we were just looking at before, I'm going to wait for the data to be received. So this is the part of the loop that pulls down the data that's been sent to it. And this first kind of part will print out the data that it receives. So it prints out like a hex character that it received. But let's put in a little check down here to see if I get a plus or a minus sign. So if I say like if my C, which is the character I received, if that equals a plus sign, then I want to turn on the LED. So we'll do a digital write on pin 5 of high. And then I want to see else if C is a minus, I want to turn off the LED. So turn off the LED, and we'll do digital write on pin 5 of low. And that's really all I need. Oops, oh, this is the example, so yeah, sure, we'll save this as BLEUART LED. So we'll save that. We'll just make sure it compiles, and then we'll upload it to the device. And one little gotcha I noticed also, if you're using things like any of the Feather M0s or maybe even any Arduino. So I'm using the latest OS X El Capitan, I think 10.11 version, and I've noticed it changed its whole USB stack, and so there's all kinds of little USB bugs. So there's a little bit of a quirk where I actually have to explicitly put my device into the bootloader kind of programming mode, or else I can't upload to it. So I'll show you kind of what happens here. Basically, if I try to do an upload right now, it's probably going to fail, and it gives you kind of this weird error message. So if you're using El Capitan, oh, this actually worked. So sometimes it fails. Like here, if I try and upload again, I have a feeling it's going to fail. Because it seems like if the USB device changes in some way, then El Capitan doesn't recognize it. Okay, maybe it's working. So if you do run into weird problems on the Feather M0 with the BLE friend here, you can double press the reset button. So if I press that twice, and you can see the red LED here starts glowing. So that means the bootloader is waiting to receive code. And now if I upload, this will always work no matter what, even if there's some crazy bug, as long as the USB device can be open. Oh, cute. Okay, so that actually failed. So this is all happening in reverse. Like normally I was getting this error when it wasn't in the bootloader. So you do have to be kind of quick because it only stays in this bootloader mode for a few seconds. So I pressed that. Now I'm going to press upload, and this should upload to the device. So, okay, I think it's going now. There we go. That worked. So just kind of word of the wise, be careful with OS X El Capitan. The USB stack changed. It's caused all kinds of problems. Like pretty much every USB library has bugs against it now because people are like, why doesn't this work on El Capitan? So just be aware of that. Okay, so we uploaded our code. Now, hopefully, in theory, if I connect to the device, so I'll disconnect on the Bluefruit friend here, and it's waiting to connect to the device. So let's connect again, and I go into my UART console, so I can still send hello world. We should still see all that. LED, nothing happened there, but let's send a plus and see what happens. So okay, cool, the LED just turned on, so you can see it lit up over there. And let's send a minus, and okay, cool, the LED turns off. And I can even kind of put these in a string if I want, like hello plus, and this should print out everything and turn on the LED, and we'll just do a minus to turn it off there. So that's kind of cool. That's kind of showing, here's some easy ways to just do basic wireless communication. My Mac right here is able to control this little Bluefruit device. This could be like a relay instead of an LED, so that if I wanted to turn something on or off, just using Bluetooth, I can do that. Okay, so I'll disconnect now. So that was the Bluefruit LE desktop app that I just kind of wanted to demo a little bit here. There'll be links in the description. You can check it out. It's in beta, like I said, but it seems to work pretty well on different platforms. So the next thing I wanted to do is maybe dive into how I built this a little bit. I'm not going to go too far into it, but in particular, one of the libraries that I used to communicate with Bluetooth Low Energy devices using JavaScript. So it's this library called Noble that you can find on GitHub, and I'll put a link down here also. And I wanted to highlight it because it's a really well put together library. Seems to be updated pretty frequently, seems to be well maintained. And like I said earlier, it supports almost every platform. So it supports Windows 7, Windows 8, Windows 10 I assume it supports. It supports Mac OS 10 and Linux devices also. And so that's a pretty broad range of support because like I had said earlier in the first video, Bluetooth Low Energy support is still pretty new for most operating systems. Like Windows 7 technically doesn't have any support at all. Now the way Noble gets around Windows 7 is it actually implements talking to a USB Bluetooth adapter directly, so it just skips the whole Windows driver stack. And so because of that, it means it only works with certain devices. But luckily, it's the same device that we have in the Adafruit store. It's the CSR 8510. I think it lists further down here somewhere in the description which device it works with. Maybe it must mention down, yeah, so a compatible Bluetooth adapter. They don't mention here, but the CSR 8510 works. So I have used this on Windows 7 and it works really well. But it's nice in that it gives you a standard API so that if you wanted to write a cross-platform Bluetooth Low Energy app, use Noble and you've got pretty much every platform ready to go right there. Now it does use Node.js, like I said, which is a JavaScript environment, so that might be new to some folks. But like I said, it's not that hard of a transition to make coming from a language like Python. They're all dynamic languages. It's just everything is in a slightly different kind of syntax or format for it. So definitely something to consider. So like I was saying before, the Bluetooth desktop app that we were just looking at, I built this in Electron, which is a JavaScript framework for building desktop apps, and it can link to Node.js libraries like this Noble library. And so because I built it in Electron, I linked into Noble. I'm able to use Noble's APIs to scan for Bluetooth devices, to find them and display them. And so what I wanted to do is maybe connect to the Raspberry Pi again and install Noble and just run a very basic application to connect to my little Bluefruit friend here and toggle the LED, like turn it on and off using Bluetooth Low Energy programmatically, so from a little JavaScript program here. So we'll go back to the Raspberry Pi right here, and I'm connected to it. Now I've done a little bit of work ahead of time. I won't do all the code because it's a little bit complex, but we'll look at the code that I created ahead of time. But I wanted to show real quickly how to install Node.js on the Raspberry Pi, because there are a lot of ways to do it. There's some old instructions that you probably don't want to follow. It's only within the last couple years that like the Node.js project has kind of stabilized and formalized, like, okay, what version we're going to have. There used to be a forked version of it called io.js, and that merged back in. So nowadays it's pretty clear, like there's one way to use Node.js, but maybe 2 years ago it was a little bit crazy and fractured. So that, unfortunately, when you go and search for like how to install Node.js on a Raspberry Pi, you'll find a bunch of different ways to do it. Some people mention just build it from source. You can install it from the apt-get repos. I'll show you kind of a little hybrid approach that I think works well. So you can install Node.js from the apt-get repositories, but you're going to get a little bit older version that way. But once you have that installed, you can install a tool called N, just the letter N. And it's a tool that will actually install the latest versions of Node.js over top of your current Node install. And it lets you swap between like older and different versions of it. So basically you kind of bootstrap your system, get a basic Node.js installed from the repository, then use the N tool to give you the latest and greatest. Because I was just using Noble, and you do have to have kind of the most recent version of Node.js. Like the one that I pulled out of the apt-get repository wouldn't compile it. It was just too old for working with it. So to install Node.js on the Raspberry Pi, connect to it. You want to do an apt-get update. I'll just run this real fast. This will just make sure your packages are all up to date, and pull down any new metadata. I'll just cancel out of this actually because it'll probably take a little while I'm streaming here. So now what you want to do is you want to install the packages from the repository. So apt-get install, and this is where it gets a little tricky. So you might think, oh, I just want to install Node. But Node, this is not the Node.js package in Debian or Raspbian Linux. It's actually I think it's like some kind of database adapter. So it's kind of weird. It's a very common stumbling block. You actually want to install Node.js-legacy, and what this does is this will install Node.js, and then it'll also install Node.js under the normal name that it has. Like normally you run Node to start the Node.js interpreter, and in Debian they actually changed the name to be Node.js, and that can cause a bunch of confusion. It makes a lot of libraries and things not work, but luckily they added this Node.js-legacy package. So if you install this package, it installs Node the way it's meant to be installed, like under the correct name. And then there's one other package. You need to install npm, which is the Node package manager, and this is kind of how you install libraries in Node. So it's like the pip package manager in Python, if you're ever kind of familiar with that. So we'll install this, and it looks like we lost a light. One of the batteries just died on the light, but that's okay. We don't really need it. It's the workbench light here. So I've actually already installed these. It's telling me it's the newest version. So I figured it's a somewhat time-consuming install. It has to download a lot of stuff. But after you install these, then you'll have a version of Node installed, but it's going to be an older version. You can run node-v, and this will print out the version. Now, I currently am using the latest version. You'll probably see an older version, like 0.12 sometimes, and that just means that it's not the latest version that you want. But what you can do is, so install this package like I was mentioning called n. So do sudo npm install -g n. And what this does is it tells npm to install globally on the machine the n package. So I'll do this, and I've actually done this ahead of time too, but we'll just kind of see what it does. So it just downloads it, it installs it. Now if I run n-help, this is going to give me a little bit of information about n. So this is basically a tool to install different versions of Node and then swap between them. And there's a command here you can run n-latest, and this will just go and just grab the latest version of Node.js, install it on your machine, and you're ready to go. And it'll replace the current Node.js so that when you run it, you'll see the version. You can also just get a list of all the versions that are installed. So like you can do, if I just run n right now, it's telling me that I have Node 5.71 installed, which I think is the latest version. So you can just kind of Control-C out of that. So that's kind of useful. You can have multiple versions. You can swap between them. But to install the latest version, just do sudo n-latest, and this will go and pull down the latest version. I already have it installed, so nothing really happened here. But that's ultimately what you want to do. So then you can run node-v, and you should see that 5.7.1 or probably even later version when you run this. So that's kind of I think the easy way to get Node.js installed on the Raspberry Pi. There might be easier ways, but this is a good way to get the latest. And then if you want to update, like if you realize you need an even later version, you can just use that n tool to install the latest one again and swap between them there. So so now that I've got Node.js installed, now I can install the Noble library. And so what I want to do is I'm going to go into a Noble test directory. So I'll just make a little directory. And the way the packages work in Node.js, you can install a package locally where it just puts it into a directory so that your code in that directory can use that package, or you can install the package globally so that any code on your machine can import that library. I'm going to install it just in this directory. When you install libraries globally, especially libraries that change a lot, like or that might be still in development, you might run into problems where some code needs an old version and your current code needs the current version, and now you've got a conflict. So it's usually easiest to keep all your dependencies local to here. So the way to install this, you just do npm install noble, N-O-B-L-E library, and this will go through and this will pull down all of the dependencies and things that it has. And one quick thing I should mention too, so I didn't mention it right now, but I've already installed the Blues source code on this machine, and so like I said before, I just went through and followed the steps in this guide right here. So I downloaded the Blues source code, compiled it, and installed it. So you want to make sure you do that before you do the the Noble install. So this went through. I had actually already installed in this directory, so you don't see much happening here. But it's giving me some warnings, but you usually don't have to worry about these. You know, if it actually says error, then it'll fail, and you'll see there's usually some kind of a problem. So this is good. So it installed in, and all that it really did, it created this node modules directory, and then inside of here is where it installed the Noble library. And when it installs Noble, it will actually compile code. Like there's a little extension it has to compile. So you know, just something to be aware of, that it's an install that takes maybe about like 2 or 3 minutes or so. It's, you know, not super time consuming, but it's not immediate. So okay, so in this directory then, I've connected to my Raspberry Pi ahead of time, and I've got some code here that we'll look at. So I have this noble test.js, and first maybe I'll run this code and we'll see what it does. So I'm going to run sudo node, and let's point it at my noble test.js, and watch the workbench over here, and we'll see kind of what happens. So powered on, it found a device, and it connected to it, and now you see the LED is blinking here. So it's blinking once a second. And what happened is my script, it looked for this Bluefruit LE device, it connected to it, it discovered all the services, it found the UART service, and it's actually sending a plus and a minus command to the little UART. And like we just saw in the sketch that I had updated, you know, whenever I send the plus, it turns on the LED, and whenever I send the minus, it turns off the LED. So basically this script is controlling this little Bluefruit device by just sending it data over that UART connection. So if I cancel this script, we'll kind of look at the code a little bit in more detail here to see how to use the Noble library. Now, if you are using Noble, you'll definitely want to go to their GitHub repository, and the documentation is mostly in the README here. So it goes through and talks a little bit about, you know, what are the functions you can call on this device. Now, if you're new to JavaScript, I'll also kind of walk through some little quirks about it. The big thing with Node.js is that everything is asynchronous, so that, you know, if you call a function that has to do some work, usually what happens is you call a function to start that process, and then your code just immediately continues on to the next instruction. And you can give it like a callback function to say, okay, you know, maybe turn on the BLE radio and start scanning, and when you find a device, call this function. And then, you know, once you find a device, then you can maybe connect to it. And that's also asynchronous, so that when you connect to a device, you have to give it a function that says, okay, call this function once you're connected. And then you can go and do different things. So that's why when you look at this code, it doesn't look like a very, you know, procedural function where you've just got one command and it waits for it to finish, and then the next command and it waits for it to finish. So that's kind of a big paradigm shift that you see in a lot of JavaScript and Node.js code, where everything turns into this asynchronous kind of calling style. And it's not necessarily better or worse, it's just different, and you kind of have to wrap your head around a little bit. You can lead to kind of ugly code. You know, I forget what they call it, but basically you have so many callbacks that are nested within each other that your code just keeps kind of marching further to the right. And there are ways to deal with that that I won't really get into right now. But it's just something to be aware of, that, you know, everything kind of happens asynchronously. So if you're used to a synchronous API where you call the function, it does all the processing and it returns when it's done, it doesn't work that way in JavaScript, mostly for efficiency. So it's actually good that it's asynchronous, because, you know, you're not waiting, you're not tying up the CPU, waiting for this Bluetooth stuff to happen. Your program can go on and do other stuff. So it lets you be more efficient, but it also means that your code gets a little more complex here. And so basically the way that I use Noble, you know, the very first line here is effectively importing the Noble library. So it's just using this require function. That's going to pull in the Noble library. It's going to search locally first. So, you know, that node modules directory, like I mentioned, that's where Noble was installed. It's going to find it there. If it doesn't find it locally, it's going to look for it globally. If it doesn't find it there, then it'll just throw an error and it won't work. But it imports the Noble library. And then I do something where I register a state change event handler. So I do this noble.on state change, and then I give it a function here to call. And so this is a callback. So whenever this state change event fires from Noble, it's going to call my code here, and it just passes in the new state. So Noble has a concept of what state it's in. So it could be in like a powered down state or powered up state. And the README mentions it here. It says, you know, you must be in a powered on state before you do anything with Bluetooth Low Energy, before like scanning for devices and things. So that's kind of what this check is doing. This is basically saying, okay, tell Noble that I want to listen to those state changes, and if I get a state change that tells me that I'm powered on, then print out to the console that I'm powered on, and then call this start scanning function. So this turns on the Bluetooth Low Energy scanning to look for new devices. And the next kind of block of code here says, okay, register a function for the discover event from Noble. And the discover event is sent whenever a new device is found. So, you know, your program starts up, it'll get a power on event that says Noble is ready to go. And luckily, that's not like a global event that only ever happens once. It seems to be whenever you run your program, you know, even if your device is already powered up, it's going to give you that event. So this is a good place to kind of put your initialization and like start your scanning for devices. So again, I register a function over here that says, what do I want to do when I discover a new device? You know, I can print out some info about it. So like I say, okay, I found the device, and I'm printing out the address of the device. So like I maybe mentioned in the first video, you know, Bluetooth Low Energy devices, they all have a unique ID. It's like a MAC address that uniquely identifies that device. And so in this code, I'm actually looking explicitly for this device, this bluefruit device. So I know the address ahead of time. Actually, we could just change this. Let's print out this device object. So we can just print out device, and we can see all the attributes on this object. So if I run this, we should get a whole bunch of data that's printed out to the screen. So you can see here's a whole bunch of data, and this is basically that device object. And so you can see all the attributes of it. Now the interesting ones are down here. So you can see it has that address. So this is the address that uniquely identifies it. There's an ID and a UUID. This is just like a unique identifier that Blues internally assigns to it, if I remember correctly, or it might even be Noble that assigns this, but it's like a unique ID that's not necessarily the address, but it's more for the library. The address is actually the Bluetooth Low Energy address of the device, though, so this is kind of a good value that you can kind of trust, and you know that it's not going to change. Tells you a little bit about it. The interesting thing here is this advertisement object that's sent in. So this is telling me that it saw an advertisement for this device, and there was some information in that advertisement. So it has a name, like the Adafruit Bluefruit LE name here. So it's just a little string that's sent in the advertisement packet. And then it also has some service UUIDs. And so this is in an advertisement packet. A device can send in the UUIDs of services that it implements, so that if something's looking for that kind of a device, it can look at the advertisements and say, okay, you know, I see this Adafruit device, and I see it has this service UUID, and this is just a fixed value. So this is actually the UART service UUID. And so if I had some code that wanted to look for a device that implemented the UART protocol, it could just look for any device that advertises the UART UUID in the advertisement here. So, you know, in your code, you can go through and inspect this advertisement object, see, you know, what's inside of here. There could be multiple service UUIDs. There is a limit on how much data an advertisement packet can send. Can't remember offhand. It's on the order of like only a few hundred bytes at most, or maybe even less than 100 bytes. So there's not a lot of data you can pack into here, but you can do things like say, you know, hey, I'm a UART device, connect to me, and you can expect to find a UART service here. So that's basically some of the attributes on the device. Now my code, once it finds the device, it basically says, okay, I'm gonna, you know, this device callback gets called, I'll print out some info on it. I look and see, is this device a special address that I'm looking for ahead of time? So like I mentioned, you know, I knew this address ahead of time, so I can look for it. You know, an alternative here could be I could look at the advertisement data, see if it implements this UART service, and then maybe use that as my logic to connect to it. But once that I know it's a device I want to connect to, you know, I'll print out some info, say, okay, I found it. Then I stop scanning. So this is generally pretty important. Most Bluetooth Low Energy APIs kind of require this, where before you connect to a device, you have to tell your hardware to stop scanning. I don't know if it's a limit in the protocol so much as maybe just in the hardwares and the APIs right now, where you can either be scanning or connected to a device. But you stop the scanning, and then on that device, I call this connect object. And so this tells Noble to go connect to that device. And you have to give it a callback because, again, this is all asynchronous code. So, you know, this is going to kick off the connection process. and then I'm just passing inline a whole new function here. And this is pretty typical for most JavaScript code, where you can just define your function inline here. You could define these functions all ahead of time, up above, and then just give the name of the function that you want. But in this case, it's a simple script, so we'll just define it all inline here. But I'm giving it a callback to say, okay, now once you're connected, the code right here will start running. And at this point now, I can start interacting with this device. But one important thing, before you can really talk to a Bluetooth Low Energy device, you need to understand like what are the services and the characteristics that device exposes. So there's this service discovery phase that kind of has to happen. And that's what this big function here does, this discover all services and characteristics function. So this tells Noble to start that characteristic and service discovery. And then again, it takes another callback function here. So, I'm already like 2 levels deep into callbacks here. And so this function will be called once that service discovery is complete. Because right now, before that service discovery is complete, Noble doesn't know what services this object exposes and what characteristics it has. And it has to know those before it can actually tell the device, I want to write to your UART transmit characteristic. Well, it has to know like the handle of that characteristic. And so that means that discovery has to happen. So, pretty much in all of your Bluetooth Low Energy code, you're going to see the same pattern of like turn on scanning, look for a device, turn off scanning, connect to the device, do the service discovery, kick that off. Then once your service discovery is done, you're pretty much ready to go. Like this is now when the main code starts to run in here that says, okay, I've connected to a device. I know that it's has the services that I expect, and so now I can start doing things with them. So what I do here, so this callback gets passed in a few things, and in general in this script, all of my callbacks get passed in an error function or error value. I'm not checking that error value, but in most code you probably should be checking that, because if that connect failed for some reason, it'll actually populate this error attribute or parameter with what happened or something went wrong. So it's something not shown, but to be aware of that these things can fail, and that's what makes your asynchronous code even more complex, because now you've got to deal with like, okay, what happens when it fails? Now do something, versus what happens if it succeeds, like do something else. So again, just different kind of style to get used to in JavaScript here with all this asynchronous stuff. But once I've connected, so I want to find the UART TX or transmit characteristic. So like I mentioned before, the UART service just has 2 characteristics. There's one for receiving data from the device and one for sending data. So the sending one is what I want, the UART TX characteristic. And the way I do that is I actually just loop through all the characteristics. So they're all passed in just as a big array of characteristics. And I just use a for each function here to say, okay, go through all the characteristics and run this function on them. And this function is just looking to see what's the UUID, the unique ID of this characteristic, and is it a value that I know ahead of time. So this value is the UART service characteristic. And we could go back to the Bluefruit app again and connect to this device and just see the services that are exposed here. So oops, let me open this thing up again. Oh, looks like it's already running, so let me quit that and then run it. And we can see the devices and the characteristics again. So we connect here, and so you can see like here are all the services. So that UART service again here, so like here are the 2 characteristics. So one of these characteristics, and let's see, I always forget how these ones differ. So there's like a UUID, oh I guess the one here, so tell me the property. So this characteristic is writable, so this one must be the UART transmit characteristic here. And I just noticed there must be a bug here where the UUID for all these characteristics is the same, so I'll have to look at that later. That's something a little odd. But basically I've looked ahead of time, I know this is the transmit characteristic, and I just saved that value. So all this code is doing is looking through the characteristics, find the one with the known UUID, and grab that. Then I just want to check and see, did I actually find a characteristic? And if I didn't, immediately quit the program. This shouldn't happen because, in theory, I've connected my device. I know the services this device exposes, but it's just smart to check this. And now the actual meat of the code here. So this is what's blinking the LED on this device, is this little block of code. And it looks a little funky because, again, JavaScript and Node.js is all asynchronous. And so, in the Arduino world, it's pretty easy to blink an LED. You just say, okay, turn the signal high, delay for a second, turn the signal low, delay for a second, and just repeat that over and over. In Node.js, there really isn't a delay function. Like you can import a library, I think, that adds one, but it's not really a delay in the sense of, stopping the whole program from running, because Node.js is all asynchronous, and if you did a delay, that's going to block everything from running, and so you really don't want to do that. So the way you kind of get around this is you have to start thinking more in the JavaScript mindset of asynchronous things. So you call this set interval function, which lets you give it a function to call at a certain frequency. So like I want to blink my LED every second, and so set interval takes a number of milliseconds. So if I pass it 1,000 milliseconds, this will call some function every second, and so I give it a callback right here, or a function to call. And so now in my function I can say, okay, now let's do the blinking logic, and I have to change a little bit to say, keep track of what was the previous value I sent, like to turn it on or to turn it off, and just swap that value. And so I basically say, okay, we'll create a little variable called command that just keeps track of what command to send next to the device. And then in set interval, I'll tell it, okay, run a function every second, and in the code of that function, on my UART characteristic, write out the command value, and then swap to the next value. So if I just wrote a plus, the next value will be a minus. And then the set interval function is going to make sure that this callback gets called every second or every 1,000 milliseconds. And so it's just going to swap between those two values. And the only weird thing to note here is that in Noble, when you write to a characteristic, you have to use a Node.js buffer. So you can't just write a string object. You'll actually get an error message back here. And the buffer is just like an array of bytes. Python has a very similar concept. There's like a byte array. It's just in a lot of these dynamic languages that kind of mix text and data processing, sometimes you want to deal with text, sometimes you want to deal with binary data. So the buffer is kind of like just an array of binary data for Node. So, and luckily you can pass it a string and it'll just turn that string into the bytes that it needs. So that's what I do here is I just create a buffer from my command value, call this write function, and that will go and actually cause the Bluetooth radio on the Raspberry Pi to send a write value to my little UART friend here, the little BLE friend. So let's run my script again just to see the blinking on here. So it's powered on, and it's going to look for the device. Oh, actually, so this is interesting. So I just ran this. You'll see it's not actually connecting to my device yet. And that's because I forgot I'm still connected in my Bluefruit application here. So my UART friend, the little M0 Bluetooth board here, it has a connection open to my Mac right now because my Mac is looking at the UART service on here, and actually like I can send it a negative value, a negative sign to turn off the LED. And because of that, my program on the Raspberry Pi, I just ran it, it's looking for this device, but it can't find it. And that's because once this device is connected, it stops sending out those advertisements and those broadcasts, because like I said before, the Bluetooth device can you can just have one connection from your master device like my Mac to a peripheral right here. And like technically you can have more than one connection, like my peripheral or my master, my Mac can actually have multiple peripherals connected to it. But in practice, most of the libraries and things only support just one connection. So anyways, my Mac is connected. It's basically stolen the connection, and so now my Raspberry Pi code can't see it. So let's see what happens if I disconnect my Mac. We should see my Node.js code discover that device and connect to it pretty quickly. Like the advertisement only happens at a certain kind of millisecond frequency. But let's see, I'll click disconnect, and okay, wow, it just kind of immediately fired up. So this disconnected, and now you can actually see here my Mac, it's scanning and it doesn't see the Bluefruit device because again, now my Raspberry Pi is connected. So the code over here ran, it said, okay, I found my device. We printed out the device like I added. We found it, and now this main loop here is running. So the set interval function, it's being called every 1,000 milliseconds, every second, and it's just writing out a new value. So it's writing out like a plus, minus, and actually if I go to the serial monitor on the Arduino over here, you can see we see the plus minus getting sent to it over here, and you can see of course also the LED is turning on. So that's kind of cool. It's basically a little walkthrough of, we've got a program written in Node.js and JavaScript here. using the Noble library. And it's not too complex, so it's maybe 50 lines of code here. It is a little complex because it's all using the async callback style in JavaScript. There are some ways to improve this and make this a little more procedural. You can use things, there's like promises where you can return an object that says, okay, I'm going to do something asynchronously, and when it finishes, you can call a function to see if it's completed. Maybe in a future video I might look at some of that stuff. But overall, it's not too crazy. I mean, the basic paradigm is that you scan for devices, you find a device based on, either maybe you know its address ahead of time, or you look at the advertisement data and see kind of what are the services that it's exposing. Then you stop scanning, you connect to it, you do the service discovery, you find the characteristics you want to interact with, and then you can just read and write data from them. So I'm only showing writing data right here, but there are also read functions you can call to say, I want to read data from here. So maybe a future example could be like a little UART console just from the Raspberry Pi here to send in and receive data. So that's kind of the basic code. I think that's pretty much all that I wanted to show for this stream. So if folks have questions, maybe send them into the chat right now. And we'll see, see if we kind of answer some stuff here. So again, like I was saying, this is using, the Raspberry Pi 3. They're out there. Definitely pick them up. They're pretty nice. I've had one for a couple days now. It looks like Bluetooth Low Energy works. I had heard reports though that it wasn't working. So, take it with a grain of salt. Like, maybe something works, maybe it doesn't. It's still early days in the Raspberry Pi 3. There are probably going to be a few little firmware issues and things to deal with. I remember the Pi 2 had the fun little photograph issue where you took a flash photo of it and it messed with some of the power ICs on there. So that could be actually a fun stream to try later. I should pull out my camera flash and see if the Pi 3 is still susceptible to the flash of doom for this. So I don't see much. Let's see. So in the chat, there's a question: does the Bluefruit LE connect to Adafruit IO? Great question. So there is kind of no bridge between like Bluetooth Low Energy and the internet that we have right now. There are some protocols for that. Like I've heard of this thing called like 6LoWPAN or something like that, where you can kind of have a device that's connected to both like Wi-Fi and Bluetooth and then kind of forward between the two. So just purely from a Bluetooth Low Energy device, it alone can't send to Adafruit IO. But if you connect that device to like a phone, your phone has a Bluetooth Low Energy radio, and it probably has a connection to like the cell networks or Wi-Fi. The Adafruit Bluefruit LE phone applications, the iOS app and the Android app, or the Android app for sure, I can't remember if the iOS app has it yet or not, they actually have a mode where it can receive data from a connected Bluetooth device and send that data to Adafruit IO, or actually any MQTT server. So Adafruit IO has an MQTT interface. There's a tutorial actually that I did with Becky, maybe 4 or 5 months ago when I was back out in New York, that you can look at. I'll link in the description of that one. And so that kind of shows we did exactly that. We had a little hat with a light sensor on it, and it connected to a phone using Bluetooth Low Energy, and then the phone sent that data to Adafruit IO. So that's definitely a cool subject. Maybe for a future video I should look at kind of doing that kind of interaction with it. So I think that was it with all the questions. So I'll wrap up this stream. Maybe we'll switch back to the main view here. So oops, there we go. And hopefully this works. I noticed the CPU usage goes a little high, so we'll try and keep this mode down. I might have to get rid of the animation. That might be causing all the CPU fun. So anyways, thanks a lot for watching. Definitely check out youtube.com/Adafruit. I'll post this video up, and if you couldn't watch it, if there were some stream issues, check out YouTube and it should be there. And then check out also twitch.tv/Adafruit. That's where I try to stream these things live too. And you can see all kinds of great stuff. Lots of streams and things that are going on. So, keep an eye on there and you'll see all kinds of new fun stuff. Desk of Lady Ada, Noah and Pedro streaming stuff. So all kinds of fun stuff. Thanks a lot, and I'll see you guys next week.